Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Well, I've got my Aloha shirt on today. Is it Friday? Of course not. It's Tuesday, though, and it's the equinox. So happy equinox. Happy fall equinox. I have a few fall equinox stories for you, and a few more that just pop in my head too. Hey, you need a white sheet, so you got to have a white sheet. So if you'll make sure you've got a white sheet, need your textbook. So you need your textbook. I have an announcement about the activities at the end of the period. Did you pick a winner in the contest? I did. Are you going to tell us right now? I am not. I will do that shortly. Anyway, 6:30 a.m. this morning was the official start of fall. Now here we are in Phoenix, and it doesn't seem like it, does it? So anyway, but I looked at the weather forecast for the week ahead, and it's going to continue to cool down in the morning. Out here in Mesa, remember I'm in the bunker in Mesa. Out here in Mesa, it's going to be in the low 70s later in the week. I just had a little conversation with Scratch, and Scratch would like a little FaceTime. So there you go, Scratch. Little FaceTime right there. Okay, see you later. We'll talk later. Go. Adios. Okay. So anyway, back to the equinox. Remember I said I'd give you 5 points. If you mention to someone, I'll make it all day long. All right, I'll make it all day. If you mention to somebody that it's the equinox, that the equinox occurred at 6:30 a.m. this morning officially, if you'll tell them that, and also tell them what it means. It's the first official day of fall. I'll pay you 5 points. But what I really want you to have in the back of your head is this, and would you look at this? I missed a wonderful opportunity to use my favorite model. It's all right. I've got one right here. I've got a model right here. Here's the sun, and here's the earth. Remember, my fingers are the northern hemisphere. My palm represents the southern hemisphere. So this was June 22nd. We're tilted. It's not that much of a tilt, Mr. C. I know. It's about 23.5 degrees from the vertical. So close, huh? So anyway, summer in the northern hemisphere, including Phoenix, June 22nd. So July, August, and then September. And if I move this around, you could see, it's hard for you to see, and I'd break my wrist. So that in the fall position or in the spring position, I suppose I could do it over here. This will be the vernal equinox in the spring, March 22nd-ish. Anyway, at the equinox positions, the sun is directly over the equator. So there's about equal daylight and darkness at the equator. Okay? So, and in the northern and southern hemisphere as well for a short time. And then it begins to change. So right now we're losing minutes every day. The sun is rising later. You've noticed that. It's setting earlier. And starting about next weekend, we'll actually have a small amount more of, I'm not going to say darkness because it's not true darkness, but we're having more on the daylight side. Now it's switched over. And my daughters down in Australia are gradually getting more and more daylight because it's the official start of spring for them, and then they're on their way towards summer. They're moving towards summer in December. So anyway, I'll talk more about that in December when we do the winter solstice here and summer solstice down in Australia, down in the southern hemisphere. So anyway, so talk to someone about it. That'll be fine. So I've got a couple of by the ways. I just gave you the one by the way, that sunrise, sunset time about equal. Have you noticed, by the way, have you noticed that the sun is coming up almost straight in the east? And it's setting almost straight in the west. Because of it, because a lot of streets are laid out east-west, I've heard there tends to, around sunrise and sunset times, at the equinox, more probability, more chance for an accident, a car accident, just because it's hard to see. You're driving and squinting and you've got the visor down. Anyway, you've probably noticed your mom or dad driving around sunset time, and that's a little bit of an issue. So anyway, that's a by the way. Here's another by the way for you. Because my dad was in the military, in the Air Force, his last duty station, I'll try it again, duty station, was Grand Forks, North Dakota, about 100 miles south of the Canadian border. So what were your Septembers like? What were your first days of fall like? They were coolish. It was already starting to turn cool, and I think there were probably some September 21st or 2nd when we were up there where we might have had frost. So it would have been below 32 degrees Fahrenheit, 0 degrees Celsius. So anyway, North Dakota. And just for fun, I looked to see if it had ever snowed in September in North Dakota, in Grand Forks. You know what I discovered? There were only 2 months that it hasn't snowed in Grand Forks, North Dakota. What do you think? Hypothesis, please. July and August, those 2 months. So it had snowed in September in the past. So anyway, that's North Dakota for you. So in fact, when I was playing on the University of North Dakota baseball team, my brief college career, my freshman year, on May 15th, we had snow flurries. Yeah, snow flurries. It was cold, really cold. Hard to bat. Bees in the bats, as they say, if you hit an inside pitch. So anyway, last thing. So the sun is shining straight down on the equator today. So if you were at the equator or near the equator, boy, you'd need to break out the sunblock, because you would be getting very concentrated UV rays and you'd get sunburned very quickly. So anyway, oh, here's that second, by the way, I promised. Have you noticed the orangishness of the sun at sunrise? Now, you never stare at the sun directly at it. It's, you'll damage your eyes. And also at sunset, but you off to the side, you can kind of see it. Never stare at it. So you can see that it's orangish. Why? What's the reason? Well, right now, there's so much smoke particles in the air from the California fires that they're filtering the light to the orange color of the spectrum. So the other colors aren't let through. They're blocked by the particles of smoke, but the orange colors of the spectrum are allowed through. Hence the orangishness of the sun at sunrise and sunset. Okay, a little bit of review. Wanted to review Psalm 139, 13, and 14. You know, it is absolutely one of my favorite verses in all of Scripture. For you formed my inward parts. You weaved me, in my mother's womb. I praise you, for I am fearfully and wonderfully made. Wonderful are your works, aka me, and my soul knows it very well. Those two verses are super proof that you were designed and that you've got a super purpose. You hear stories of people that go, I'm just really depressed. I don't feel like there's any reason for my existence. Hey, when you know Psalm 139, 13, and 14, you go, I've got a big purpose for being alive. God has designed me. He's given me a lot of gifts and abilities to use for Him in His kingdom until it's time for me to go to heaven. I've got a massive purpose. Pretty cool. Okay, you've got a white sheet, right? Okay, get ready. You're not quite ready to write, but you're going to in a minute. All right, 3 parts of a human or an animal cell. Here they are. The outside part, membrane, the thick liquidy part on the inside, cytoplasm, and the nucleus in the center. Later in the week, you're going to get a chance to look through a microscope at some cells, and you'll clearly see their nuclei. That's plural for nucleus. So you'll clearly see them. So anyway, the 2 extra parts that a plant cell has. It's got the greenish, loaded with the green coloring, that when light hits it, it produces food, sugars for the plant. What are those parts called that have the chlorophyll? They're called chloroplasts. That's it, chloroplasts. And then you've got the thick outside border besides the membrane, a thick outside cell wall to help hold the plant up, to give it support. So, cell wall. So anyway, those 2 parts. Now on your white sheet, do a little bit of writing. It won't hurt you. So if you'll write down the 3 parts of cell theory, if you'll write those down. Cell theory on your white sheet. The first one, all living things. So I'll let you finish it. All living things are made of cells. Plants, animals, and humans, all made of cells. Number 2, second part of cell theory. Cells are the basic unit, that means part, of structure and function. The basic physical part and the function part is what the cell does, the job of a cell. We'll get to that in a minute. And number 3, how do you get a cell? How do you get more cells? They have to duplicate or reproduce. So cells come from other cells. All living things are made of cells. Cells are the basic unit of structure and function of all living things. And cells reproduce themselves and make other cells. That's where they come from. Okay. Now, coincidence? Not really. The 3 functions or jobs that cells do. GRL, grill, GRL on your white sheet. G4, R4, L4. The 3 functions of cells. What's the G one? They grow. And the R, we just did it, they reproduce or duplicate. Okay, and then the L part just means living, the living function of cells, the life part of cells. So those are the jobs that a cell does: grow, reproduce, and keep an organism alive. So anyway, Now, in your journal, you need your journal. In your journal, I would like you to, if you haven't done this already, you might have. I'd like you to put down the word microscope. 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 Is it a compound word, Mr. C? Sounds like it. You betcha. Microscope. M-I-C-R-O-S-C-O-P-E. Easy peasy to spell. Okay. What does micro mean? It means tiny. Very tiny. Micro. So, or, as I am wont to do sometimes, micro. So, above micro, put tiny. Scope. What is a scope? A scope is a viewer. You've got a telescope and you have a microscope. What exactly is a microscope? So if you'll put equals, a microscope is a viewer of tiny things. It's a viewer of tiny things. So please don't get confused. Sometimes on a quiz or test, is there a quiz or test this week? No. Well, there could be a pop quiz. Either tomorrow, Thursday, or Friday. So keep reviewing. Keep triple R'ing. Could be a pop quiz. If there's a pop quiz, it'll be small. Like 10, 12 points max. So smallish. So keep reviewing. But no big tests. Nope, no big tests this week. So when we do have a test on the microscope, I'll ask you, what exactly is a microscope? And you'll want to say it's a viewer of tiny things. Now don't get confused. Sometimes people will say the opposite. They'll reverse those two words. So anywho. Now, in your journal, so you've got microscope in your journal, there are two kinds of microscopes. Two kinds. Two kinds. The first kind of microscope are light microscopes. They use light. They magnify with these little guys. Or it could be a big guy. You got one in there? I think so. Yeah, there it is. I feel it. Yeah, here it comes. So they use lenses, light microscopes. So in a minute you're going to draw one of these kinds of lenses. Here's what they do. Let's see if I can get you to see this, move in close and scare you. Again. Probably don't want to do that to my nose. That would really look scary. You can see their magnification function. Now, this is a convex lens. So you're going to draw one on edge. So I'll move it in close like that. And you can see that it's fat in the center and skinny on the edge. Convex lens. How do you spell that? Just like it sounds. C-O-N-V-E-X. Convex lens. What does it do? It bends light. It spreads light out. Anything that where light comes through an object, it gets spread and therefore it looks bigger. So it magnifies. So you're going to write convex lenses magnify. They magnify. Okay? And so one kind of microscope, lenses magnify using light goes through the lenses and gets spread, makes it look bigger. Magnifies. Light microscopes. Second kind of microscope you've already read about, an electron microscope. So it uses a beam of electrons to magnify the object that it looks at. And the name of that kind of microscope, I'm not going to ask you. transmission electron microscope, TEM, transmission electron microscope. Uses a beam of tiny atomic particles. There's a third kind of microscope that uses positrons, which are another kind of atomic particle. So it's called, got to get it right, I'm not going to ask you, a TPM, a transmission positron microscope. Now, the bad news about an electron microscope, I'm going to read this to you, see if you can catch it. Because the beam of electrons used in electron microscopes damages live biological specimens, scientists have developed new kinds of microscopes for use with these kinds of samples. Now read between the lines. Damages the biological specimens. Mr. C, what isn't being said there? Well, a lot of the time it doesn't just damage the organism or the tissue being examined that's often on an organism. What does it do? It fries the organism, kills it. So that's why they've developed the positron beam, because they don't damage the specimens, they don't damage the tissues or the whole organism that's being examined. You know, like if you were looking at an insect or a spider or a mite, something very tiny like the mite in your book. And then they've got an additional kind of microscope that you read about in your worksheet that uses sound waves. Sound waves. What is that called? An acoustic microscope. Acoustic means sound. Okay, we have in a lot of the rooms at SCA there are acoustic tiles. What do? They absorb sound to cut down the noise, so the sound doesn't hit the ceiling and bounce around. So they absorb the sound waves. Okay, homework. Tell you about your homework. You've got your textbook. If you'll open up to page 9, please. Page 9. In your lesson planner. Page 9 and 10 in your textbook. The first thing I want you to do is I want you to do a little sketch of this microscope in your journal. Just do a little quick sketch. I don't want you to spend more than a few minutes on the sketch, the outline of it. Just really quick, sketch the outline of it. Mr. C, I couldn't draw nothing. Me either. So, but you can sketch the outline. Trace it if you have to in your journal. Okay? So, stick it in your journal. And then tomorrow I'm going to tell you parts that I want you to label. That'll be part of our activity tomorrow. I'm going to tell you certain parts that I want you to label. So do a sketch of that microscope for your journal. Then I want you to read this page right here and fill out this part right here that says a compound microscope. This little section right there. Fill that out. A compound microscope. So read that one page, page 9, and fill out the virtual lab where it says a compound microscope, 1 and 2. Then I want you to do a similar thing on page 10. I want you to read it, and I want you to stick 2 things in your journal in the microscope section. I want you where it says measuring microscopic objects. I want you to just give a couple of, like if you were giving directions about how to measure a microscopic object. It tells you right here, just tell how to do it in your journal. So you write a little quick title, measuring microscopic objects, write down how to do it. A couple of steps, 2-3 steps of how to measure a microscopic object. Then I want you to write down the word resolution. There it is right there. It's almost in focus. Resolution, and I want you to explain what it is. What is resolution? Both go in your journal. Now put them in there, okay? So get them in there. Then I want you to fill this apply it section out right here. Fill that out. Maybe even do the challenge part right there, the challenge part. But fill that out. So pages 9 and 10, read them, and then do the questions that go along with them. So that's your homework. Now, I want to say a word or two about the activities. Now, I'm pretty sure today you've got a substitute like you had yesterday. Now, here's what I expect. I expect you to be like extra polite and cooperative. Now, my guess is you've done that while I've been doing the video. Way to go. But you need to step it up over if there needs to be another day or two where there's a substitute in the room. You need to step it up to a higher level of cooperation. Like be on your extremely best cooperation. Yeah, expected, not an option. It's expected. Okay? Now, I'm going to see how this goes. So, yesterday you did the activities. You did one question. You had 5 minutes. Each of you. Evens, and then the odd-numbered folks in the room. And once you did it, you took your seat and started working on your homework. So, just one question, the usual rules for the activities, no more than 3 in a section, A, B, C, D, or the WC section, the wildcard section. No more than 3. Don't share information. Don't give me skinny answers. Give me a complete bullet fact answer. Hypothesis to the question. So do a nice job on those. And then the announcement I wanted to make, winning the contest of the name of our activity. The short version is going to be essay. And here's what it stands for. So I picked Nora Moo's submission. She submitted this from period 4, and here's what she wrote. You can see why it got my attention. Activité scientifique. Way to go, Nora. It's French. So it's French for science activity. So we'll just call them essays. So, but it's activité scientifique. So I'm butchering scientific. It's Monsieur Agiac would roll his eyes if he heard me pronounce that. You know, my UND, University of North Dakota, French professor. So you're getting 5 minutes only. So whoever the sub says, be extremely cooperative, quietly, go to your new section, no more than 3. Just write down your hypothesis, get it done quickly, get her done, take your seat, start working on your homework. The group that's working on homework first, get going on it. Okay? It's on the board, pages 9 and 10. Get with it, and then switch it up. So I know I can count on you to be extra cooperative these days. So, as they say down under, good on you, and keep it up. So the sub will tell you which group to go first and when 5 minutes is up. Adios.